Welcome back, data leaders, large language model automators, and Python experts. Mastering TxtAi, vision, speech, and data processing pipelines. Automate tasks using AI models. Welcome to Insight Builder channel. The challenge that is going to be solved in this discussion is related to speech, related to data processing, and image processing. In the earlier videos in the same playlist in my channel, you could actually look at the text processing pipelines that we discussed. So let us go to the browser for a moment. And if you visit this particular Mastering NLP with Hugging Face playlist, you will see the rest of the other videos that I have discussed upon various libraries that can speed up your NLP journey. Out of that, I have been discussing about TxtAi for a couple of videos earlier. For this particular video, I would suggest that take a look at this Hugging Face vision tasks discussion for your better understanding, because most of these models that we are going to discuss in this video has been discussed in detail from the Hugging Face vision related tasks. With that said, let us go back to the presentation to discuss more about the topics that we are going to handle. So after text, so text is ubiquitous. After text, we have speech and we have image. The structured data as a whole is present everywhere. So that is something that also we can process. But this particular video has some interesting pipelines. In TxtAi, there are some interesting pipelines that I wanted to discuss with respect to text-to-speech, and also there are a couple of related Python libraries that I wanted to introduce also. As I always say that the entire ecosystem around a particular problem involves lots of when it comes to image processing and speech, text, and data processing, let us dive into the code and understand it better. So regarding the various pipelines, the benefits of it I have already discussed in the earlier video, but I would like to just touch the important parts of it. The pipeline functions or the pipeline construct in TxtAi is abstracting away the transformer pipeline that is underlying the Hugging Face transformers library. So that's what I was telling you guys, that take a look at my Hugging Face video that I have already shown in this video. You will get a better understanding. Pipeline in TxtAi also helps to directly identify the best model for a particular task. In case of Hugging Face transformers model, one has to know which model to use. But in case of TxtAi pipeline, you actually don't need to know that. You can just initiate the pipeline and the pipeline class does all the automation for you guys. That is one of the benefits, but also it's also one of the disadvantages. As I always say in my videos, that abstraction can be a challenge if you don't understand what is going on beneath the surface. So we'll be going under the surface also, and we'll be showing you the models that is used for these vision related tasks and various other tasks that we are going to discuss. And TxtAi does not actually shows you the model that it uses. So that's a good thing about TxtAi that I wanted to also share with you guys. The pipeline also has a benefit of streamlining the data ingestion and data outputs. You can work with pipelines along with the workflows construct inside TxtAi. That will be discussed later in this series. The most important point when it comes to this image processing and speech text processing is that once the unstructured data like speech, text, image, whatever that we are talking about is embedded or converted into numbers, then we can actually use other ways of doing search on that particular embedded vector space. So you must have been, if you see my earlier videos, we have been discussing about text searching using vector spaces and vector stores. So that can be also leveraged for image processing too. However, in this video, we are not going to discuss to that level. We are going to understand how to process the image, how to check the caption, how to identify the objects inside the image, how to work on hashing the image, etc. So we'll be diving deep into that right now with the code that is already shared with you guys in the GitHub repo. The link for this code, this particular Jupyter Notebook will be shared to you in the description of this video. So I hope that you like this video. Do leave a like, share it with others, because this technology is new. As I have been telling, TxtAi has been around for quite a long time. That's something that I did not even look for, because I was not having the idea that okay, the problems that I am having would have been already solved. So once I got that idea that yes, the problem that I am having will be already solved, will be automatic, already automated, led me to search for these libraries, led me to look for various developers who are already working on these technologies and see what they have already contributed. In that way I could come and locate, I could find and work with these libraries like TxtAi, Haystack, LangChain, various other libraries, unstructured, 2V, all these libraries that I have already discussed in my playlist. So I hope that you like it, and do subscribe to my channel. So further updates on these kinds of libraries, the various AI related tasks will be shared to you to your YouTube dashboard directly. With that said, let us go to the browser and start looking at the code right now. The code, as I already told, will be shared with you guys. The this particular GitHub repo link will be there in the YouTube description below. Let us go to the Collab notebook directly. This Collab notebook I have already started it, and I have run the Collab notebook so that it can save time. You can see that the RAM, almost 6 GB of RAM is getting used here, because the models have been already loaded into the runtime. The libraries that you will be using is specifically TxtAi all version, where all the dependencies are downloaded. We will be using also ONNX runtime GPU version and Librosa library for working with text-to-speech. Also, we will be, when I started researching about text-to-speech, I came across a couple of other related libraries too, which TxtAi guys had shared with me. First and foremost, it is ESP.net library. This is the base library on which the text-to-speech models are getting hosted, and there is also a related library called as MuseKits. It's not Muskits, so I read it as Muskits initially. It is music related library. So you guys do explore these libraries. I'm not going to right now discuss them here, but the text-to-speech and speech-to-text conversion models are related to ESP.net library. So that's something that I wanted to highlight here. The pipeline related to text-to-speech and speech-to-text. So both are available inside TxtAi. So text-to-speech pipeline is called as text-to-speech, while speech-to-text, that is audio-to-text, is called as transcription. So you will see that one by one. In order to initiate the pipeline, we have to just call the pipeline class. So that initiates it and also pulls down the model. And once the model is pulled down, all you need to do is give the text that you want to convert. So this is already done here. You can so I will just execute it again here, because I want to show you the model that is getting used, because that is more important, correct? I have already executed it, and once you check this out, so if you check the TTS object, so you can see that TTS object contains various methods that is linked with it. So you see the input, the max tokens, the model. So click on the model and check the model. So all of the things, you see this, so it actually gives the complete detail here, and it's a method here. So execute the method and check the model. What happens is sometimes the inference session does not give you the model. Okay, so don't worry about that. When you are starting this particular notebook, and once you execute it, you can actually see the model getting printed down here. Okay, just a minute. Okay, coming to the step where you actually give the English text that you are going to convert. So all you need to do is write a sentence and say, here I'm asking what you like to talk about, and I'm converting it into speech object. So this speech object, you can display it inside Jupyter Notebook itself. For that, you can use ipython.display, and there is a method called a sound file that also you can use, and then you can display the audio file. So this is the process, or this is the wrapper function that does that. So here you see that, yeah, here you just now heard, once I click the play button, you just now heard the data that came out of the voice that came out of this particular sentence that I had created. So this is how the text to speech works. Now the same speech object, so this speech object is the, okay, let us look at the speech object. That's more interesting actually. If you take a look at the speech object by itself is just an array. So this is what I want you guys to see. And this speech object has been converted to numbers, and which can be read by various encoders that convert it to sound. So this is how the entire process works. So it's, again, as I always say, that unstructured data like speech, text, image, whatever it is, it gets converted to numbers, and the models, the AI models, only look at the numbers. It does not understand your speech, it does not understand the language, it just looks at the numbers, and it actually gives out numbers only. Once you get the numbers, the programs like the audio, the display, the sound file, these libraries work with those numbers and convert those numbers back into audio that we can hear. So there is a process, there is a pre-process and there is a post-processing happening here. We need to understand these things also. When you look at the documentation of TxtAi, the documentation only discusses about this step, these 2 lines. However, the examples that TxtAi provides, that actually shares you all these steps, the pre-processing and the post-processing. So that is one of the things that I realized after I started researching. So this is something that I wanted to share with you guys also. And here you see that FFmpeg. So this particular application is native to Linux. So this is not, sorry for the disturbance. We were discussing regarding the FFmpeg application, which is native to Linux, that is used to convert the WAV format file into MP3 format, and that MP3 format is then used to display as audio in this particular function. So this is a wrapper function that is working out inside the Jupyter Notebook environment. So when you're going to work in your regular environment, this is going to be a little bit different step that you'll be following. So in case of your regular environment, we may not be able to use this kind of exclamation mark. I have not tested it, but still, if I'll be testing this out, and I'll be sharing with you guys if there is any challenge in this part. Once that is done, so we saw how it can be converted from text to speech. And there is a transcription pipeline which is opposite of text to speech, which is speech to text. So if you have a WAV file, that is, if you have a MP3 or a WAV file, then you can convert that to text. So there is an OpenAI Whisper base. This is a Whisper base model. This is not the model that is that came recently from OpenAI. This is a base model that is already available as open source inside the Hugging Face Hub, and that model is getting used. When you are going to use that model, we need to provide the rate at which the audio file is available. So that is 22,050 hertz. That is the audio file is available. And once you give that rate along with the WAV file, then you can transcribe it into the output. So you see the output is like what you like to talk about. So you see that we started with what you want, what you like to talk about. We converted it to speech, and then we converted the speech, that is the WAV file, and converted it back to text again. So you see the entire cycle, right? And these steps can be done on multiple files also. It need not be curtailed to single file. You can actually create workflows that involve multiple WAV files, which can be then fed into these models, and then the text can be generated for all these files. And the TxtAi makes this process very intuitive. Now that is on. Let us go back to the presentation for a moment. So we discussed right now this text to speech and speech to text pipelines. Next, we will be talking about data processing pipelines. So data processing pipelines is very much it works basically with CSV files and the text files that is available in the internet, and working with the sentences that is provided available in the internet. So segmentation segments the text that is provided to it into semantically logical segments, and then tabular takes the text data and converts that text data into a format which is easily embeddable inside the vector stores or indexes, and text extraction actually extracts the data that is required for us. So from the URLs and internet using Tika, Apache Tika, and or Beautiful Soup 4, so BS4 that is. So we'll be looking at that right now. Let us go back to the browser. In the browser, you can see that we start by using NLTK. We have to import the NLTK library. Ensure that you do that. It also comes by default installed here in this case, because we are doing a TxtAI all installation. So all the necessary runtimes, necessary libraries are already installed. And we download the punct tokenizer here from the NLTK that is used by the segmentation construct here. So there are segmentation actually works on multiple options. So we can have lines equal to true, paragraphs equal to true. So there are various other options available. So if you give sentences equal to true and segment it, so it will segment based on the sentence. And if you use paragraph equal to true, then it will do accordingly. So it will segment it based on the paragraphs. So you can try this out. This is pretty intuitive. It's not something that's very difficult. And I think it is using basic machine language related tokenizers, not neural network related tokenizers. So that is something that you can try it out. Next is working with tabular pipeline. So what tabular pipeline does is it takes a CSV file. So this CSV file is the COVID related CSV file. This CSV file has been shared by the TxtAI examples only. So this is the file that I'm using. Only thing I'm making it different is instead of in the examples, the example calls for 10,000 rows, but I'm only using 100 rows here because it is easier to show and process. Because if it is 10,000 rows, I will not be able to show this input CSV file. It becomes bigger and it is difficult to show it here. But we can use other methods to show it, but it's still not very intuitive. So you see the card UID, the source, the title. So this is the title, this is the UID, and you can actually, just a minute, sorry. So you can take a look at the various, there are lots of other columns also here, so you can take a look at that. What we are going to do is that we are going to take the URL and we are going to take the title from this series of columns inside the file. So the tabular pipeline that when we initiate it, we are going to give this ahead of time. And then once you initiate the tabular pipeline, then you give the input CSV. So once you do this, then actually you get the output like this. So the rest of the columns will get removed. Only the columns that you're asking, that is URL and the title. So only that will be provided as an output. So also this particular output is very similar to the input that is required for embedding. So let me show you at the bottom. So here there is another way where you can actually work with the tabular data. When you say this true value here, this means the rest of the content also will come along with this tabular data. Why this is useful is that whenever you want to work with embedding, you can also embed the content also. So once you create the tabular data like this and then create send the input CSV, the output will be still similar to what you see here. The output will not change. But once you do this in the embedding, so there is embedding class. Let me go down. So there is this embedding class. Once you embed this data inside the embedding class and then start querying this embedding class, then you can actually get all the columns that is available inside this input file. So understand this concept very clearly. The tabular pipeline only gives the output that you are showing here, that is URL and title. It will not actually get the other columns that is inside the CSV file. That is something that you need to be clearly aware of. But once you embed these details, once you embed this data and give this input.csv, at that time the embeddings the embedding will know that there are additional columns inside the CSV file, and it can be selected using the SQL class that already I discussed about. I will be attaching that information, that particular video also here. So do try to practice this out, and if you have any questions related to this, we can discuss. That will be much more interesting actually. So this is something that I wanted to highlight in case of tabular workflow. Now here you see that a couple of things I've already done, and you can see the output here. So I am only calling the URL and title, correct? But here at the bottom I have already embedded the data. Here I've already done it because it takes time. Here I am actually asking for the title, abstract, authors, DOI. All these things I did not actually ask in tabular column, correct? But after I embed, I can still get those data. So that is what I was trying to say. Let me show you guys. This is something that I really, so you see the abstract and authors, even though I did not embed it, even though in the tabular _1, if you go here, I have created only URL and title. I have not done any kind of additional embedding, but once I use this select clause, I can get the rest of the data also. This is one of the things that I find little different in TxtAi, and how it is used for working with SQL. So it's one of the interesting aspects I wanted to share. Now, the next pipeline that I wanted to discuss about is text extractor. So this particular pipeline works with various URLs, that is websites, and it extracts the data from those websites. So here I have shown my GitHub repo page, and once I use the extract, it extracts all the text inside the GitHub repo. So this will either use Tika or it will use Beautiful Soup 4, depending on the availability. And this is the output that you get. This extracts all the output, so it does not segregate whether that output is required to you or not. It extracts all the output inside the HTML file. This is about TxtAi. I am giving you a very high level overview of what is available, and also this particular notebook is available with you, and you can try different URLs here. And it's not just that you have to work with one URL. You can work with series of URL by creating a workflow on top of this TxtAi. That is also possible. So these things we will be discussing later in this series of videos that I wanted to share with you guys. Okay, so let us go back to the PDF again, and we had completed speech to text. We have understood what is data processing. Now we are entering the most interesting aspect, that is image processing. In image processing, there are three pipelines available. One is caption, another is image hashing, and another is object. So caption, what it does is it takes the image and returns a caption that describes the image. The second one, the image hash, creates a hash based on the data that is taken from the images. The third, the objects, it actually detects the object inside the image and it shares, it returns to us. So all these things are pretty intuitive to understand, but you will see how easy it is to implement. Let us go to the browser. In the browser, we see that we can use this ipyplot is one of the plotting libraries that is required to show the images. So that is why I have installed this. This was again shared by TxtAi guys. And this particular examples are also taken from TxtAi guys. You can work with other examples also. This is available to me and it was easier to share it, so I am using this. Here, the first and foremost, I'm using the caption pipeline. So once I implement the caption pipeline, you see that it is using VIT GPT-2 Coco. So this is the model that is getting used, and the model card, you can find it out here. The point here is that you can actually send in the captions, send in the images, and each image inside this particular glob will get captioned. And once those captions are created, so you can see the captions here. So let me actually show the captions directly to you, so that it will be more easier for you to understand. So I am sending, okay, so the images that you see here inside the TxtAi folder, you will see a lot of images. Okay, so let me double click. I think I can see the images. Yeah, we can see the images actually. So you can see the various images that is already available here inside this particular folder that has been downloaded from the GitHub repo. And these are already captioned, and you see the caption is not same as object detection. Understand that very clearly. So caption returns a text snippet talking about or describing the particular picture that it is captioned. The object detection is different. So let us, I will show the difference in a couple of minutes. So this is the caption, and this particular step where I use ipyplot and plot the images is basically plotting these captions along with the image. So you can try this out. Next is where object detection works. So in this case of object detection, there is also already one of the videos where I discuss about the object detection. Let me go to the NLP playlist. So in this playlist, I discuss about the, I think I have not included it here. Okay, so in the already one of the playlists, I discuss about the segment anything model that has been introduced by Facebook. That Facebook is really doing great strides in OCR as well as in object detection and various vision related models. So do follow Facebook for various such models, and also they're pretty ahead in the recommendation models also. Recently I've been reviewing one of their models for market analysis, that is market gap analysis, as well as the recommendation system that is used for multiple products. They have a very intuitive library for that also. They have created that library in R, but they are yet to release it in Python. So once that Python library is available, I'll be discussing that too. So let us go back to the discussion among here. So this object pipeline gets initiated, and inside the objects we can again send the images that we already have got, and this time the detected images are going to be different. So let me show you. So detected is the variable that contains the various images objects here. So you see that we see there is a clock, there is a bird, there is a vase, there is a motorcycle and person. In some cases it's not even detecting anything. This is because of the model's shortcoming. So if you have a different model, instead of using Facebook DETR ResNet, if you use a different model, then you are going to get a different output here. So this is something that I wanted to tell you guys. The caption that you get is completely different. So caption model is giving all the caption model is giving the caption for all the images, but the object detection model, in certain cases, it's unable to detect the object at all. So probably the object is blurred enough, or the object is not matching with any of the classification that is already available inside the model. So there could be other reasons also, but this is something that you guys have to understand. That's why I'm showing it to you guys. Okay, so we have discussed about the object detection. We have discussed about the caption also. Finally, we have image hash. You must have already been aware of hashing algorithms. So you give a particular number or a particular series of numbers to a hashing algorithm, you get out a hash. So this hash is very unique. You cannot change it that easily. What I meant to say is, if you change the source numbers or source file, source image, then the hash will immediately change. So here the hash is used on the images that is available to us, and we get the details. So we can use this hash for creating indexes also. So this particular class is what starts the hashing pipeline, and this particular hashing pipeline takes the image and it gives out the various hash. Once you get the hash, you can use that to index also, like using this particular you see this index. So I'm using it here, and I can get the image from this particular index. So you can use it like a form of embedding. but you cannot use it for searching. So you understand the difference, right? The vector embedding is totally different from hash indexing. So don't get confused between these two. Image embedding and searching through image is going to be taken separately. I'll be working on that in future video to give you a comparison. But right now, understand that this index with this hash is similar to. So practice this particular step. You will understand better once you experiment with this in the notebook that you have. So with that, we have come to an end of this particular discussion that we are having. So here you see that I have used an index and I have cropped the particular index here. So I am showing this this particular file, the bigger file, to you guys. And here I have chosen the file, and I am this is the index that I am choosing. This is the index, and from that index I am choosing the image that I am going to use, and I am getting the size of the image, and then I am cropping that image from the center, and then that cropped image I am using it in search. I am using it under show. So if you go to show wrapper function, so this show wrapper will actually take the image and it will return the image as a resized image. So this is what is happening here. And this particular function that we are right now working on, image.resize, it is already initiated above. So this is what I was trying to discuss. Now let us go to the PDF for a moment. So here we already saw the various pipelines here, the text-to-speech, transcription, the various data processing, and the various image processing pipelines. You must have got an idea, the overview of the entire pipeline options that is available in TxtAi right now. Do take a look at my earlier video on text processing pipelines also to get further updates. And as I always say, that use this notebook and start practicing these pipelines, because only once you practice this, it becomes more intuitive. Yeah, I say that it is very intuitive to begin with, but that is because that once you practice it, once you see the objects and the data in action, data in flow, then it becomes very clear that how the data is getting converted. Like in the video I was showing how the speech is actually, the speech variable is actually an array of numbers, and these numbers are what gets looked at by the models and gets processed. So that is what I was talking about. And once you see these things in action, then it will be much more easier for you guys to practice and also understand it better. I hope that you like this content. Do leave a like and share it with others. Subscribe to my channel for further updates on similar kind of libraries, artificial intelligence models, large language models, and discussion on Python ecosystem available around AI topics. With that said, I would like to leave this end this video with 4 words as usual, that is practice, 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 practice. See you guys and have a great time.